Okay, so today we're going to finish up with elimination method, and this is part 2, so we're going to eliminate. Yesterday we did adding, subtracting. Today we're going to eliminate by multiplying or dividing. All right, so let's look at our notes here. It says, what if there are no common coefficients? So, like if you look at number 1, you got x plus 3y and 2x minus 7y. Well, we don't have any coefficients that are the same or the opposite. So we couldn't do add or subtract there. So that's where multiply or divide comes into play. All right. So what you're going to do is to multiply 1 or both equations by some number to create matching or opposite coefficients. All right, so last time we were just add or subtract coefficients that were the same or the opposite. So now what we're going to do, we're going to multiply one of the equations to make it where they're the opposite or the same. Okay, so let's look at this one. For the x's, I've got 1 and 2 as my coefficients. For the y's, I got 3 and negative 7. All right, so I can make them the same, make them match, if I multiply the first equation by 2, then I would get 2x plus 6y equals 12. So now, if with the second equation, all I have to do is subtract, and I can cancel out my x's. Okay, so by multiplying that first equation by 2, I was able to match the coefficients of a variable in order to eliminate by adding or subtracting. All right, so we're going to subtract 2 minus 2x, 2x minus 2x is 0. 6y minus negative 7y minus a negative is plus, right? So that'd be 13y equals 12 minus negative 1. Well, that's 13. So y is going to equal 1. So now I'm going to go up here, and you can use either equation. I'm going to substitute 1 for y in the first equation. So x plus 3 equals 6 minus 3. So x equals 3. So my solution would be 3, the ordered pair 3, 1. Okay, so yeah, when we're adding, subtracting, we have to have matching coefficients. Either they're matching or they're the opposite. Okay, that way we can add or subtract. So if they're not, we're going to multiply one of the equations by a number that will create matching or opposite coefficients. All right, so if I look at this one, the coefficients for x are 2 and 9. Well, I'd have to multiply the first one by 2 and the second one by 9 to get matching coefficients. But let's look at y and see what I would have to do. So I got 3 and 1. So if I multiply the second equation by 3, then that's going to give me 6x plus 3y equals 15. All right, so instead of that, I've got this now. So I got 3 y's, they match. So I can just subtract those. So 9x minus 6x is 3x, and 3y minus 3y is 0. Bring down your equal. 12 minus 15 is negative 3, so x equals negative 1. All right, so I'm going to go plug it into one of the other equations. 2x plus negative 1 equals 5. So this is 2x minus 1 equals 5. You're going to add 1. So 2x equals 6. So x equals 3. Oh, I plugged it in the wrong thing, didn't I? Huh? So I plugged the x in for y. My bad. All right, 2x, so x is negative 1 plus y equals 5. So this is negative 2, so we're going to add 2 to both sides, so y equals 7. So my solution is the ordered pair negative 1, 7. All right, let's go down to number 5. All right, so I can do 2 different things. So if I've got 1 and 5 or 1 and negative 2. So you can multiply by the first equation by 5, or you can multiply, the first equation by negative 2. Either one doesn't matter. Or you can multiply it by 2. So let's do that. 2's smaller. All right, so we're going to get 2x plus 2y equals negative 6. So now, if I add these together, negative 2 and 2, they'll cancel out. So we get 5x plus 2x is 7x. The y's cancel out. Bring down your equal. Negative 50 plus negative 6 is negative 56. So we divide by 7, and we get negative 8. Okay, so now I'm going to go replace x in one of the equations with negative 8. So we're going to add 8 to both sides, so y equals 5. So my solution is negative 8 and 5. All right. Okay, let's look at number 8. This one's a little different. All right, we got 3 and 5 and 3 and 4. All right, so I don't have any that it's just a 1. So it means I'm going to have to multiply to either get a common multiple or either multiply them by each other. So if I multiply this by 4 and I multiply this by 3, then I'm going to end up with 12x plus 12y equals 36. And then I multiply by 3 on the bottom, so I get 15x plus 12y equals 30. So now I've got 12 as a matching coefficient. All right, so I'm going to subtract them. So 12 minus 15 is negative 3x. 12y minus 12y cancels out. And then bring down your equal. 36 minus 30 is 6. Divide by negative 3. So x is negative 2. And then I'm going to plug it in to I'm going to pick my first equation and replace x with -2. So this is -6 plus 3y equals 9. So we're going to add 6. So 3y equals 15. So y equals 5. So my solution is the ordered pair -2, 5. All right. Yeah, neither one of my coefficients was 1. So that means we're going to have to multiply and either get a common multiple or multiply the one variable by the coefficient of the other variable. Okay, so this was 3, so I multiplied the other equation by 3. And this one was 4, so I multiplied the other equation by 4. And when I do that, 3 times 4 is 12, 3 times 4 is 12, okay? So if you can't think of a common multiple that's smaller than that, then you're just going to multiply them with each other, okay? Let me see if there's... Okay, let's look at let's look at number 10. All right, so first off, remember we have to keep them lined up, correct? So the equal sign needs to be over the equal sign, so I need to bring this over here. So when you get 2x minus 4y equals 18, and this is going to be -5x minus 6y equals 3. All right, so everything's lined up. So now I'm going to look at the coefficients. I've got 2 and -5, and -4 and -6. Okay, so 2 and 5 and 4 and 6. So neither one of them are matching or the opposite. So you can multiply by numbers to get a common multiple. If you remember a common multiple, if I said, what are the multiples of 2? Well, it'd be 2 times 1 is 2, 2 times 2 is 4, 2 times 3 is 6, 2 times 4 is 8. So these are the multiples of 2, okay? What are the multiples of 5? Well, it'd be 5 times 1, 5 times 2 is 10, 5 times 3 is 15, okay? And if you look at 4 and 6, what are the multiples of 4? 4 times 1, 4 times 2 is 8, 4 times 3 is 12, 4 times 4 is 16. And if you look at the multiples of 6, 6 times 1 is 6, 6 times 2 is 12. Okay, so we could have a matching of 12, or really we could carry that on, and 2 times 5 is 10, and we could do a common multiple of 10. All right, either one will work, but this one's smaller, let's do 12. So we're going to look at a common multiple of 12. So what would I have to multiply with 4 to get 12? 3. And what would I have to multiply with 6 to get 12? 2. Okay? 4 and 6 have a common multiple of 12. What do you multiply with 4 to get 12? 3. What do you multiply with 6 to get 12? 2. Okay? So now I'm going to multiply these out to get my new equations. 6x minus 12y equals 30, 50, 54. And then be negative 10x minus 12y equals 6. Alright, so I've got coefficients that are the exact same, so I'm going to have to subtract this equation. So 6x minus negative 10x, so minus a negative is plus, right? So it'd be 16x. Negative 12 minus negative 12 cancels out. 54 minus 6 would be 48. And then we divide by 16, and we're going to get 3. Okay, so now I can go back to any equation, go back to an original here. Let's just do the first one, 2x. So 2 times 3 equals 4y plus 18. Okay, so 6 equals 4y plus 18. So I'm going to subtract 18 from both sides. So negative 12 equals 4y. So negative 3 equals y. So my coefficient is going to be 3, negative 3. Okay. All right. Yeah, I'll leave some of these for we can do those in class tomorrow. Okay. So when you get to these, just think, what's the number I can multiply to make them the same? Okay. All right, y'all have a good evening. Thanks.